Yes, sir. Shall we start, sir?
Yes, sir. Good morning.
Shall we start, sir? Yes, sir.
Yes, sir. Good morning. Is it audible now?
Okay. Okay. Yes, sir. Good morning to all the participants. Welcome to this third day of the one-line online FDP on integrating Autodesk Fusion 360 in engineering drawing. I hope you have learned much from the last 2 days. For today's session, we'll continue with Mr. Ria, sir. He will be teaching us on assembly motion studies as well as generative design. So I give this time to sir. Ria, sir, over to you.
Thank you, sir. Hi, good morning, all. So let us start with generative design today. So last 2 days, what we have covered actually so far it is so solid modeling, and then how we going to create how we can create a model in a Fusion 360, and then how it can be assembled, and also how we can create the freeform features with the help of Fusion 360. So far we have learned how to create the model, and then so the different components of the model we can create in Fusion 360. After creating the different components, we may get into the assembly environment, and then we may assemble each component with some joints, with the help of some joints and constraints that we can do it in the assembly part. And also we had created not only a solid part model, we have created a freeform model actually. So that it can be just any kind of complex based model or any kind of universal shape of model we can create with the help of freeform model actually. So we have created the model with the help of the freeform models, and then we had assembled those models. That is, we had assembled both solid model and also freeform model. So with the help of some joint constraints, what are available in assembly. So today let us move on to the generative design. So we all know artificial intelligence is playing a vital role. So not only in computer science engineering, so even the first day of our FDP session, Mr. Rajesh sir from Autodesk had said that actually artificial intelligence plays not only a role on computer science department, so it plays happens on everywhere in each and every field of engineering or any field actually. Not only engineering field, even like uh, not content writing, anything like. So now the artificial intelligence becomes a part and part. So it's purely depends upon that thing actually. So we all know that artificial intelligence is nothing but, for my observation, actually, we going to give some intelligence to the machines. So based upon our predefined algorithms and then predefined data. So based upon the data what we had followed so far. So based on that, we give some inputs and we give some based upon with the help of algorithms to the machines. So the machine going to be react as like that. So based upon the our inputs. So the machine is automatically think and then act accordingly. So as like that, we have some design roles also. So normally what we are doing as of now means we are creating designs based upon our mechanical calculations, right? So based upon some lot of formulas, calculations, equations, and then conditions, situations. So based on that, we are creating designs and then environmental conditions. So a lot of things are there. So so it is also we have to give inputs. See, if I need to create a model means what I have to do, I have to create the sketch and I have to convert that into a solid part model, and then I have to give some dimensions for that. See, for even if I draw a line, I have to give the length of the line. If I create a circle, I have to give the radius or diameter of the circle actually. For each and everything, if I create a rectangle, I have to give the input as length and width. If I create a box, I have to give the length, width, and height actually. And then if I create a cylinder, I have to give the what radius and then height. If I have to create a sphere, I have to create a if I have to create a sphere, I have to give the radius of that one, and then I have to where it has to be created, even the point of creation. Not only for sphere, actually, it all applicable for box, rectangle, whatever it may be. Actually. So we have to give the position where it has to be created, and then we have to give the exact dimensions. So as like this, that's only so far we have created. So what we had did after the creation of the models. So after that we will analyze. So before computer engineering or analysis, what we had did, example, we had did a crash test for a car. So it may cost something like very higher while
Sir,
compared with the production cost.
excuse me, sir.
Sorry,
Sir, are
sorry,
you
sir.
sharing your screen, sir?
Not, no, 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 no,
Okay,
not yet.
okay. All right. Yes, sir.
So lot of things what we had, okay. So far what we had did, so we based upon the calculations and then we had did analysis. After analysis, we will consider the best solution. We may get exact dimensions and what the dimensions it may be of the component and what the shape of the component should be. Based on that, we had go for manufacturing. So everything that cost time, a lot of things are evolving, and then we are giving lot of what permutation combination methods. We are using some permutation combination methods, lot of permutations and combinations methods. While this artificial comes to the role, all these mind work and mind calculations are carried by machines itself. As like that, only the generative design is also. So we're going to generate a design based on our environmental conditions and then based upon our design conditions criteria, we can easily create the any kind of designs. So that only we're going to do in this generative design. Okay. Okay. So let me share my screen. Let me share my Fusion 360 screen actually. Now let us open the day 3 folder. So today we're going to see generative design, then motion analysis. So here for generative design, I'm going to consider a jet engine bracket actually. We're going to generate a design for a jet engine bracket. Okay. So before, okay, let me open this one actually. So this is my model setup. Let me hide the data panel now. So based on these conditions, based upon this model setup, we going to create a jet engine bracket. Okay, before getting into this, we have to know about how the jet engine bracket looks like and what are the things it might be like. So let me stop the screen and then share the image of the connectivity. Show it out. Okay. So this is an image of a jet engine. So two arms it may be there. So this it may be fixed. That is four areas, bolted areas. Here it is mentioned as bolt areas, right? So here the areas are fixed actually. So this is our main body. So this is our main body, and then these two portions are the pin areas. So where we going to assemble with the engine part actually. So this bracket is important for a jet engine actually. Okay. So for creating for generating this design only, we're going to implement the generative design in Fusion 360. Okay. Now let us go to the Fusion 360 window. So we are thinking that this in this area only that Z engine bracket going to be get assembled. Okay. So this it may be called as a pin area, and these four corners it may be a bolted areas actually, right? So let us consider these four areas it may be a bolted end, and this should be the pin area. These two area are the pin area where it going to be get connected. Okay. Okay. So this is the model we had created for our generative design. Okay. So here, what are the bodies here actually? The very first thing is base. Very first thing is base actually. So the base and then the four bosses are there actually. And then ring one is at the pin area actually. So this is on the another end actually. The ring is on the, so this is also maybe a pin area on both the sides. And then this it may be considered as a pin actually. This it may be considered as a pin. And then these are the fixed constraints. So I already said no. So these are the created for the fixed constraints because these all the four edges are fixed, right? So this it may be considered as a fixed constraint. So for that, the four models are there actually. Okay. So this is not actually model. So this is a model setup. Here only we're going to generate the model. Here only we're going to generate the model. For generating model, we are creating some setups. So this is that setup actually. Okay. Okay. Now let us switch over to the generative design. So how to generate, how to change our workspace from design to generative design? So we have to click on our workspace. We have to click on the workspace. In that, the second option is generative design. So let me click on the generative design. So now a window appears whether we have to select it actually. So whether we are going to generative generate a design for a structural component or a fluid path. So now we're going to create a for a structural component. It is not a fluid path. So we're going to create a we're going to create a design for a structural component. So we have to study about that one. So before creating that, we have to give some conditions, loads, environmental conditions. So all these things we have to apply, right? So that is it may be called as a study. That is it may be called as a study actually. So that's why here it represented as a new generative study. So that's why here it is represented as a new generative design, as a new generative study, whether it is for a structural component or fluid path. So anything you can do it actually. So the fluid path, it's like this actually. So whether here we're going to create for this one or this one. So we're going to create for structural component. So let me choose structural component and then click on create study. See if I click on create study, see what will happen. The model has come. The model is here actually. And then lot of predefined options are there actually. See, this is a study one option, structural component. So because we are we are clicked on structural component study, right? So that's why here this mentioned as a study one, it has a structural component. Excuse me. Okay. So now let us see one by one actually. So what are the things available here? So first, actually, it is a generative design. So that's why it is mentioned as a generative design. And what kind of units you have to use for the generative design. So it actually it is a custom. So if you need to change, you can change it. And then generative model. So this is the model which we already created. So that's why it is represented as a generative model. And then named views, actually this is a usual one. So front, top view, side view, actually all these things. And then origin is also, this it maybe comes from model itself, because we had created this model. So that is also it comes from model itself. And then model components. What are the components available here? So we all only one component, that is G bracket. In that different bodies are there. So that is base, ring. So these are the things we had seen in modeling environment. So only the same model is came over here for generative design. Okay. So for so only so the all the bodies are which was created by us in G bracket is showing here. So these are the model components. What are the components? The model component in a model actually. So different bodies. So base, same ring, and then pin, and then fixed construct. Okay. So let us close this one. Now comes to the structural component. So this is the first study, study one. This is a structural component. So as like this, you can create n number of studies. As like this, you can create n number of studies. So this is the study one actually. So if you need to add one more study, then you can go ahead with. So new generative design, yes, that you can go ahead. Okay. So and then here, the very first thing is preserve geometry. Very first thing is preserve geometry. So preserve geometry, what we have to do, so actually the same thing is available here. So let me show it here. So let me move my cursor over the preserve geometry icon. Okay. Let me paste here. See, what is the preserve geometry? Assign the preserve geometry to the selected body or bodies. Assign a preserve geometry to incorporate bodies in the final shape of the design. These bodies don't change during the generation of outcomes. See, if you generate a design, these are the portions that does not change. That thing it may be called as a preserved geometry. See, here in this image itself, it shows in green in color. Here it shows in green in color actually. See in the first image, that are all the things shown in green in color. And then see the second image, the same thing, it is highlighted with the green color box. It is not changed. So those places which should not change, that we have to select as a preserved geometry. In our model, which are the preserved geometry? These four constraints, that is in four fixed edges, four fixed points, that it may be considered as a preserved geometry. Okay. And then the next one is obstacle geometry. Obstacle geometry is what it is actually. Assign obstacle geometry to bodies that represent empty space where material is not placed during the generation of outcomes. So we have to assign some body or geometry as obstacle geometry where the newly generated designs should not appear on that area. Should not appear on that area. So that area, it has to be highlighted as a obstacle geometry. So for that purpose only we have created these things actually. For that purpose only we have created these bosses, four bosses, and then base, and then this part also actually. Okay. So these are the areas, and then even this part also actually. So these are the areas where the geometry should not, that newly generated design should not components at that area actually. So because the design is going to be generated, right? So the design going to be generated, it should not be available on these areas. That is obstacle areas, obstacle geometry. So the word itself shows that obstacle. Obstacle means what? Obstacle means some restrictions. Some restrictions. Okay. So in those areas, the model should not be generated. So that it may be called as an obstacle geometry. So for that also we have to give some inputs, because we only have to give some inputs, right? So where the objects are fixed, and then where the newly generated design should not be generate any parts at that area. So everything we have to give action. That is, these are the conditions, right? So these are the conditions, environmental conditions. So we're going to give. So not only environmental conditions, we have to even give for loads also. So how much it has to be, the newly generated component has to be faced, how much load it has to be faced, what are the loads it has to be faced, in what direction it has to be faced. So that are all the things also we have to apply it. Okay. So we are seeing one by one, what are the steps, and then what are the things we have to do it. Okay. And then unassigned geometry, actually here 8 bodies are there. These are the unassigned geometries, and then we have to give the objectives. What is the objective? Whether it should be minimize the mass or any other else, or whether it has to be go to the limits. So here factory of safety is there. And then what is the manufacturing process? See, we are creating the designs for manufacturing. We are creating the designs for manufacturing. So a number of manufacturing processes are there. Milling, turning, generative, 3D printing. So these are the different kind of manufacturing processes are there. In what way you going to manufacture the generated model? So the design which you going to generate, not only for viewing purpose, that it can be go for manufacturing purpose also. Even it is supportive for manufacturing process also. So that kind of design is going to be generated in this generated design. Okay. So the design, usually what we will go, say even if the generated design is not there, means what we will go for, we will go for design for manufacturing process. So we have to create a design based upon the given conditions, and also it should be easy for manufacturing process also. So we have to create, and then we have to sit and think about how the model has to become. It should be support the, it should be satisfy the requirement, and also it should be supportive for manufacturing process also. So those things we have to consider, and then we have to develop a model. We have to create a design. But here it is not needed now. All these headaches are not there, because the system itself going to generate a design based upon the conditions what you are giving, and then based upon the loads what you are giving, based upon the constraints what you are giving, and then based upon the manufacturing process, you're going to develop that same model. So that kind of design only going to be generated here. Okay. So there is what? Not at all lot of workflows. That is what, reduction of works, and then thinking what lot of things we can say it actually. Okay. Everything is reduced. Even the design of the mass also reduced. So not only our work is reduced, even the design of mass also reduced. Even the cost of the design product also get reduced. The time taken for the manufacturing process, that also going to be reduced. Everything is going to be reduced. One thing is going to be higher. What is that? Is efficiency. While comparatively what you going to be created manually, the efficiency, it results in efficiency, right? So that efficiency is lesser comparatively with efficiency of the generative design. So time reduced, cost reduced, process reduced, headaches reduced, all these things are reduced, and then efficiency is increasing. Efficiency of the model is getting increased. Okay. Okay. For creating a generative design, what are the things we have to be done? So first thing, see, in define, actually this is a generated design environment. Here there is only one tab is there. Only one tab, that is define tab. Excuse me. Sorry. Okay. So here only one tab is there. There is different tab is there. We need not to worry about what is the process. It has to be done because we have the guide. Okay, come to the guide. So just click on the guide. See, one more panel is getting up here. That is learning panel. So here the guidance is there, and then my learning is there. So here learning, what are the things it has to be, what are the different tasks we have to do it. So complete the following task to up level your Fusion 360 learning. Okay. So these are the things we have to complete for this particular model. Okay, what we have to do, edit the model. This is an optional one. So if you need to edit, you can edit the model actually. So just click on here. So how we going to edit the model? See here the edit model is there, and then from there you can edit the model based upon the requirement. Okay. So actually this is an option one. We had created the model here, so there is no need of editing the model for in this at this time actually. And then we have to give preserve geometry. So here in design space there are options. That is preserve geometry option is there, and then obstacle geometry option is there. So preserve geometry we have to give actually, and then obstacle geometry it is an optional one. Here in this case we have to give it actually. So the areas, the material it should not be generated. So that area we have to give, right? So here we're going to give the obstacle geometry, and then constraints. So far it is not ready. So we have to apply. So if you apply constraint means automatically here that green tick mark it becomes. Loads actually it is not ready. We have to give actually. So if you apply the loads and then if you can complete the load conditions means automatically the tick mark will come here, green tick mark. And then material, see, we did not apply any material, but it is in green tick mark is there actually. Because the Fusion 360 automatically detects some material. So by default, Fusion 360 has some default materials. So while you're creating that any kind of particular model, automatically the material will apply, the default material will apply to that particular model. Okay. So that's why here the material is in green tick. So we have to change this material. So for this case, we are going to apply some new materials other than the default material. Okay. So we're going to change, and then the next is a preview. So how we going to generate the model? After that, you just click on generate. If you click on generate, automatically the design will be get generated. If the design was get generated, even the generate is also in green tick mark. Okay. So these are the different steps. Okay, sir, I don't know. These are the steps how it has been done actually. Okay, no problem, no worries. Actually, just close the learning part. See, in after the guide, what are the things it has to be generated? Each and every step. So we have to give one by one only. So this is the order we are going to proceed actually. So this is the order. The first one is we're going to create a study, and then if necessary, we have to edit the model, and then we have to give the design space. In that, especially we have to give preserve geometry and also obstacle geometry. After set up the design space, we have to give design conditions. See what are the conditions we can apply here. So just click on the design conditions. See, we can apply structural constraints. We can apply structural loads and then load case attributes, point, mass, manual actually. So these are the things that it can be done actually in design conditions. So here we're going to use structural constraints and then structural loads. Okay. And then design criteria. What is the objective? What is the objective? So in a lot of cases, we have to reduce the mass of that particular model. In a lot of cases, we have to reduce the mass of the particular mass. If you click on the design objective, see here maybe showed as minimize the mass. And one more category is maximize the stiffness. Maximize the stiffness. And what should be the so these are the things we have to specify. Now I'm not going to specify because we're going to give one by one actually. Okay? So just now I am explaining what are the process we're going to give. Just click on cancel. And the next one is manufacturing. So specifically the manufacturing constraint for the design process. In what way it has to be added? In what way it has to be get manufactured? So what are the options available? Unrestricted, additive milling. Additive means it's like additive manufacturing process. So it is nothing but 3D printing. So what the objects we're going to create with the help of 3D printing machine, that it may be called as a additive manufacturing process. Okay? And then we all know about the milling options and all. So this is the design criteria. So for what objective we going to create this generative design, and then on which manufacturing process we going to develop our generated design. Okay. The next one is materials. So here, excuse me. So here we going to give materials. Which material you can analyze it. See, even for generative process, we should not give the exact material. We may suggest some materials. So these are the materials that you can generate. On based upon the result, you may choose any one materials. For example, you may give 2 to 3 materials. You can give 2 to 3 materials. Even more actually, you can give it actually. For example, I'm saying you can give 2 to 3 materials. After analyzing part, after the design has been generated, you have to analyze the shape and design of the model. Whether it has satisfied our requirement or not. We have to check it actually. So based upon the result, we have to check whether the requirements are satisfied or not. As like that, we have to check it. So after that process, we have to conclude this material is okay, this shape or design is okay. As like that, we have to conclude it. So for that, we have to apply more number of study materials. So that kind of materials that you can apply it on this option, study materials option. And then below that, actually one more option is there, that is manage physical materials. So even physical materials also that can be changed by changing the values of the properties of the physical materials. Okay. So we had created the edit the model, we have created the model, and then we give a preserved geometry and then obstacle geometry where the material has to be generated and then where the material has not been generated. So after this setting up the design space, we have to go for edit, design the conditions, different loads. So that is structural constraints and then structural loads we have to give it. After that, we have to specify the design objective actually, whether it is for weight reduction, whether it is for weight reduction or some other else actually. That is increase the stiffness of the part actually. And then the next option is what kind of manufacturing process you're going to apply for that generated design. So that thing also we have to specify in design criteria. And then materials, for what kind of materials you needed actually. So as like that, you have to mention about the materials. Even you can add 2 to 3 or 4 or more material to a particular design. And then at last we're going to go with generate option. So in this generation option, what are the things we have to go check it? The very first option is pre-check. Pre-check, the system would automatically detects some. See, let me click on the pre-check now. See, lot of errors are there. See, cannot generate, please specify at least one, preferable two geometries to preserve. Incomplete setup, missing structure loads other than the gravity in load case. Because we didn't apply so far, we didn't apply any force on so far actually. There is no, we didn't apply any load so far in the generated model. So that's why it shows like that. So these are the different things, right? So these are the different pre-checks. Okay, let us do one by one actually. So just go ahead with the units option. By default, it is custom actually. Just let us move on to the edit icon, edit units icon. Just click on here. By default, it is custom. Let me change it to inches. Let me change it to inches. So usually we will go for metric only, right? Usually we'll go for metric only, that is millimeter, centimeter. As like that only we will go. But now I am just changing it for inches. Now I'm changing it for inches. So click on cancel. Before clicking on see, let us explain once again actually. So go ahead with this units icon here. So here I'm going to change the default unit set from custom to US based settings, just inches. Click on OK. So just click on OK now. So here the mass is mentioned as LB mass, temperature F, force LB force, length in inches. So these are the units. Just click on OK. Okay, we had set the units. What is our next thing? So go ahead, we have to go one by one, right? So we had already created study, but in study settings, if you need to refine your accuracy of the generated design, you can go ahead with this. Just click on study settings. See what the outcome image should be. Whether the resolution it should be low or whether the resolution should be high. So based upon input, it will take some time for rendering. See here there are two ends. One is low resolution and another is high resolution. So by default, it was in middle of the position actually. So let it be there itself. Let it be there itself. Just click on OK. So first guide and then study. In the study settings, actually the study settings we can give the resolution. That is the outcome resolution. And then we have to go for edit model, but here there is it is not needed actually. Here it is not needed. Because the model itself created by us only. So yeah, that is that should not be any. deviations because we only are creator. Okay, now let us go for design space. So first in design space, what we have to specify? Preserve geometry we have to specify. So before getting into this, just see this study one actually. Before getting into the design space and then while defining before defining the preserve geometry, just see this actually. So preserve geometry. Preserve geometry, it is no nothing has been selected so far, so that's why it is like this actually. And then obstacle geometry is there, everything is there actually. So let us start with preserve geometry. Let me click on the preserve geometry. So what are the here the geometry? It is a it may be called as a preserve geometry. In this model, which are all the things may consider as a preserve geometry. Can anyone answer? In this model, which are all the components we may take it as a preserved geometry?
Sir, hello, sir.
Is it?
Sir, bottom brackets, sir. The fourth part, sir.
Sorry, I can't get you, sir. So here, we may consider these four edges as the preserved geometry. So because these are the areas we may get contact with the bolt, right? So these are the bolted edges actually, the bolted portion actually. Here only we're going to fix our bracket. So we may consider these four things as the preserved geometry. So here it asks to select the body, which are the preserved geometry. Let me select all these four. See, one body is get selected, another body, number 3, number 4. Okay, see, just notice here in the browser. As of now, the preserved geometry is no. Okay, just click on OK now. See, the expansion bar is there. Let me click on here. So we had selected four bodies. Here we had selected four bodies actually. So these are the preserved geometry. Okay. And then not only that, we have to add two more things also. So let me go with the preserved geometry. Add this pin portion also. So this one, okay, this pin portion, these two also. Just click on OK. Because these are the fixed edges actually. These are the fixed edges. There should not be any changes at all there. And then see now in preserved geometry, 6 bodies are there. 1, 2, 3, 4, 5, 6. All the greenly highlighted area we may consider as a preserved geometry. Okay. Now let us click on the obstacle geometry. So what are the areas or bodies we have to consider as a obstacle geometry? So we have to choose the obstacle geometry that the newly generated component should not create. So in the area of the obstacle geometry, the object should not generate it. Okay. So as like that, we have to give the obstacle geometry. So for that, let me consider two things actually. One is base. Let me click on the base. Another one is this body actually. Let me click on this one and then click on it. See, automatically the preserved geometry portions are highlighted in green in color, and then obstacle geometry are highlighted in red in color actually. Excuse me. Sorry. See, now the obstacle geometry is also defined. So now go to the guide. See the mylining portion. See, preserves is in tick mark, obstacle is in tick mark. Edit model actually it is an option one. We didn't do for this one for actually because we need a model. So we have only created the model. So there is no error in that one. There is no need of editing option in model. So that's why it is not close. So earlier it is preserved by the earlier nearby preserve. It was mentioned as not ready. Now it is not there. Only green tick mark is there. Earlier nearby obstacles in bracket it was optional, but here that option is not there. It is in green tick mark. Okay, let me close this one. It's not needed now actually. We have designed the we have given the design space, preserve geometry and obstacle geometry. Okay, what is the next option? We have to give the design conditions. So just click on the structural constraints first, where the constraint has to be applied. Here the constraint has been applied on only four areas. That is these four corners, these four edges, that it may be fixed with the bolt connection. So that all the area it is fixed actually. So just consider. Here I have to choose the portion where I have to constrain it. So I have to apply the fixed constraint. What are the constraints? See it here actually. Let me click on here. So there are 3 to 4 constraint option is there. That is 4 constraint option is there. That is one is fixed, another one is pin, frictionless, and then remote constraint. So 4 options are there. In this we are selecting fixed constraint because we're going to fix the portions actually. So just select these surfaces. Select these surfaces. See now a lock symbol is getting appeared, but actually it is an inverted manner. Just click on OK. See, while fixing the constraints, while applying the structural constraints, the icon of that type is showing in your so the lock symbol it indicates that the fixed constraint is applied on that particular phases. So in all the axes, X, Y, Z axis. Okay, just click on OK now. So we had applied structural constraints. See, in these load cases, by default it is there actually load cases. Just let me expand these load cases. And then there are two things are there. One is load and another one is constraints. So let me expand the constraints. See the fixed constraint is there. If you need to edit this one, you just click on this edit button. It shows like a pencil. Let me click on there. See if you need to edit the faces or you need to add some faces or if you need to remove some faces, you can easily apply it here. So here the only four phases are there. So we need not to go for additional phases. So let us leave this as it is actually. Click on just OK. So if you need to edit that you can do it. So by expanding the load case, just expand the load case and then just click on what are the things you have to edit it. Whether if you need to edit the loads that you can do it here. If you need to edit the constraints that you can do it here. So let me expand the portions loads. Okay, let us close all this one. So now we had applied the constraints alone. So now what I'm going to do is I'm going to apply loads, structural loads actually. So what way I'm going to apply the load? So let me share another one screen. So this is my another one model actually. Sorry, the picture of the loading conditions. So actually it is not much clear. So just see, this is loading condition 1, this is loading condition 2. So the loading condition maybe it is upwards or downwards, or it may be crosswards, or it may be one side forward and one another side backward actually. So these are the different conditions. These different conditions only going to apply it actually. So how I derive these conditions actually? Excuse me. See here one research article is there. So this is 2021. Some case study has applied on jet engine bracket actually. So this is our jet engine bracket. So different conditions of loads are there. So initially I show you a figure no, so I had chosen from here only. Ah. So here different load cases are there. So load case 1, load case 2, load case 3, load case 4. So different cases are there. So based on this, I'm going to give some loading cases and then values and all. Okay. So how we going to apply these kind of loads in our model actually? Okay. So let me stop the screen here and then let us switch over to the Fusion 360. Go to the share and then click on Fusion 360 and then click on. So these kind of loads only we going to apply here. Oh. So now go ahead with the loading conditions. So by default the load cases is there. So just click on design conditions, go ahead with the structure load. So I need to apply loads. So I have to apply on the pin area only, but here the model is there to disturb. So let me hide the pin portion. Let me hide the pin. Just unhide it. So just I'm hiding this pin edge. Okay. So the pin portion. The next option. So where the structural load it has to be get applied. So in these two phases, this phase and then this phase. If I click on there, I can apply the structural loads based upon here. See what kind of loads you can apply it. What are the loads you can apply? That you can apply the force, or you can apply the pressure, or you can apply the moment, or you can apply bearing load, or you can apply remote force, or you can apply remote movement. So different kinds of loading options are there. Right? Here, what I'm going to do is I'm going to apply force because a bracket is usually fixed based upon the force actually. Okay. Now the force, where the force it can be, it should be at. So let us go for the different direction, the direction type. So just click on vectors XYZ. So we're going to apply force based upon the direction. So in which direction? Because what we have seen is towards upwards, towards sidewards, towards downwards. So a lot of options are showing that what the research paper. So based upon the research paper only, I'm going to apply some loads actually. So here I am applying in Y direction. Applying, sorry, not in Y direction, should be Z direction. Okay. So it should be in Z direction. That is 8,000 LB. So here I mentioned as LB, but actually it is in Newton, right? In research paper it was in Newton. So that thing you can check it off. See here changing units is there. Just click on here. If you need to find the equivalent 8,000 LB force on Newton, just click on here and then make it as Newton. See, in terms of Newton, it was mentioned as 35,585.773. So the same value it was mentioned there, but actually only the decimal values are not there. All others are same, just go with the LB force itself. So if you give apply force value on FZ means, that is on Z direction means, see that direction of force acting. So it is towards upwards. It is towards upwards. So just click on OK. By default, gravitational force it might be there. By default, the gravitational force it might be there. See, it is represented as a yellow in color. Okay, we had created one load cases. We had created one load cases. So far, what we had did, we had create a study, and then we had changed the units, and then we had given the preserved geometry area, and then we had given the obstacle geometry area, and the next is we had given some structural constraints, the 4 places, and then we are going to give structured loads. One load I had tried actually, I had applied. So for until this area we had covered actually. So go for next loads. How to apply the same kind of loading conditions by different values and different directions. So that is simple actually. Here by default the load case 1 is there. Just right click. Just right click. Just click on load. Okay, see here the load case is there. Let me right click on this, And then let us go for clone load case. Just click on clone load case. So we're going to clone means what? We're going to create the same load case in another name. Just click on this one, clone load case. See now the load case 2 is generated. Again, let me add 2 times clone load case and then clone load case. So as like this, you can create n number of load cases. Okay. So now the load case 1 is 4. Now let us activate the load case 2. If I need to activate the load case 2, what I have to do is I have to double click on the load case 2. Just double click on it. The load case 2 is get activated. So here what we're going to do, we're going to change the load values only. Just click on here. Just go with the load cases and then expand the loads. Here there is an option called force 2. In that in the force 2 nearby force 2, there's a pencil like icon is there. There you can edit your force. Let me click on here. See now a dialog box is getting appear. The name of the dialog box is edit structure load. Here I going to edit the load. So instead of FZ, I'm going to apply on FY. Here I'm going to give the value. It has changed the value as 0, FZ, and then change the value of FY. It is minus 8,500. Shall we check the value is right or wrong based upon that value, based upon what? The research paper. Shall we check? Just click on the stop sharing screen. Let me share the again. Click on share. See, these are the different loading conditions. Load case 1, a vertical static linear load of 35,586 Newton. Actually, here it is mentioned in Newton, but there it is LB. Okay, let us recheck it. If you change this LB force into Newton, see what is the value here? That is minus 37,809.88. It's approximately 810. See the what value is present over here in our research paper. Actually, it is mentioned as 37,810 actually. 37,810. 35,856. So 35,586 Newton. And then F. Actually, that is a vertical static linear. Vertical static linear. This is horizontal static linear, right? So let me stop the screen share. Now I go to the Fusion 360. Click on the share and then go to the Fusion 360. See what we are given here. We are given, if you convert that given value into Newton means it may comes around minus 37,809.884. That is the thing it is represented as 37,810. Okay. So the same thing as like our research paper only we are doing. So only 2 loads are applied in the same in that conditions. So another 2 loads are different conditions actually. Okay. So if I change it to LV means automatically it comes around minus 8,000. Let me click on OK now. See here, the two load cases are completed. Load case 1 and then load case 2. In load case 2 also, we had applied the forces actually. And then we had edited the forces. So now we going to go ahead for load case 3. Here also I'm expanding the loads option and then I'm going to edit this force 3. So here what I'm going to give is in Fy, let me give the value as minus 7060 LB. And then here it is 6357. It should be in positive value. Okay, so then just see in right hand side view. So this is the area we needed, right? So cross angle. So here we had mentioned it as Fy minus 7060. Let us go with the right side view. It is in a crossword direction. So if you change it to Newton means that also you can apply, you can change it here. Just click on Newton and then give the value based upon Newton. That is not an issue at all. Just click on OK now. See, if you go for LB force, it may be mentioned as minus 7060. If you click on Newton, the equivalent value of 7060 force, it may be getting displayed in Newton value. Minus 31,404.445. So let me click on OK now. So far what we had completed load case 1, load case 2, and then load case 3 also we had completed. So just double click on it and then do it actually. So then only that particular load case it will get activated and then the value of that thing it may be get updated. Okay, that's fine. The constraint it may be same for all the load cases. The constraint is same for all the load cases. Okay, here the load case 4 is there. Just I'm expanding the load case 4. I'm expanding the loads. Here force 4 is there. What I'm going to do is I just select that particular force and then right click and then delete it. Right click and then delete it. Because here we're going to apply some different loading conditions. So that's why I delete that load for that load case 4 actually. Just double click on the load case 4. Now just turn off the visibility of the pin. Now just turn off the visibility of the pin actually. So let me turn off the visibility of the pin. Now what I have to do is I have to apply the load on both the faces, but on the different directions. But on the different directions, opposite directions, not on different directions. We will say it in opposite direction. Okay. Okay. So let me unexpand that one actually. Okay. Now here the load we had deleted actually. Load case 4 is active, but we had deleted the load. Okay, let me choose this face. Let me choose this surface and then go to the design conditions and choose the structure loads. And choose the structure loads. So let us go with vectors option. Let me click on that one. So here there are three options, Fx, Fy and then Fz. Here we going to apply in Fy direction, that is horizontal force actually. So let us consider this it as a minus 1400 in this direction. If you apply on this direction means here it might be of opposite direction. So just click on OK. And then let me consider this surface. Apply the load. Go to the design conditions, apply the structure load. So just give in positive direction, positive value. So go to the vectors and then choose the force on y-axis, y direction will be considered as a positive direction, that it may be of 1400. See the aeromer, direction of the aeromer, that it indicates that it acts acting in opposite direction actually. So now we have completed load case 4 also. Load case 4 also we have completed. So now go ahead with the guide option. Now go ahead with the guide option. Check what are the things completed. See, we had completed the preserve geometry. We had completed the obstacle geometry. We had completed the constraints, what we needed. We had applied the constraints. We had applied the loading conditions. Materials, so far we not yet added, we have to add that one. Okay, because this is the material which is taken the default material as the input. So that's why it is in tick mark. We have to define some other materials other than the default material. Okay, so let me close this one. So the step-by-step process, that is important actually. The first we have to create the study, and then we have to, if required, we have to go for edit model, and then we have to give preserve geometry and then obstacle geometry. After that, design conditions. So after the design conditions actually, so we are applying structural constraints and then structural loads. So far we have did until this. In load part alone, what we had did is we had applied 4 different cases. So based upon these 4 cases, we going to generate a model. So the model which we going to be generate now is going to be satisfied all these 4 conditions actually, all the 4 loading conditions. Okay, the next one. The next one is design criteria. So we had completed until this design conditions. The next one is design criteria. So the design criteria is in design criteria, the first one is objective. Let me click on objective. Here, what is my objective? Here I have to minimize the mass of the bracket. That is jet bracket, design jet bracket. We have to minimize the mass of the design jet bracket. For that only, I'm going to create this study. Okay, so if you need to maximize the stiffness, then you can choose maximum stiffness. But actually, this study is for minimizing the mass of the Z bracket. So let us leave the objective as it is, as minimize mass. And then what would be the factor of safety? Here we have to mention. By default, it was 2. Actually, the factor of safety is also 2 only. By default, it is 2 only. So just leave as it is, what they mentioned in the objectives. If you need some changes, sir, if you need to change the factor of safety to some other value, means you can change it. Sir, if you need to change the objective, because I need to create a design to maximize the stiffness, means you can change it to you change the objective from minimize the mass to maximize the stiffness. So that is not a problem at all. Okay. So here we have here by default it is minimize the mass and then factor of safety is 2. That is our objective also. Okay. So that's why I'm leaving the things, whatever things is present by default, just let me leave the thing as it is and then click on OK. Then only the objective may be taken as for consideration. Just click on OK. Don't give it cancel, just click on OK. Okay. Now go to the guide option, check it. Preview. So until this we have completed. The next one, we have to give some manufacturing criteria. So before getting into this, so let us continue this from this after the manufacturing, after our break actually. Okay, so let us take a small break and then we will move on to the next portion. Okay. So before getting into the break, is there any doubt so far? Any queries so far what we have covered?
Okay, participants, if you have any questions, please use the hand raise option. I will unmute you so that you can ask a question. So I don't think they have any doubts as per now, sir.
Okay, sir. Okay. Okay, sir. Now let us leave for a break and then we
Yes,
will
sir.
continue after a break. So
Yes, sir.
sharply by 11:30 we will start.
Yes, sir. Okay.
Fine. Thank
Thank
you.
you, sir. Thank you. Dear participants, we shall have a break for 10 minutes and we will resume the session at 11:30. Please note, we will resume the session within 10 minutes at 11:30.
Sir, shall we resume?
Yes, sir. We can start.
Okay, sir.
Yes. Sir.
So let me share the screen, I think.
You're already the co-host, sir. You can share your screen.
Ah, yes,
Yes, sir, your screen is visible.
fine, sir, fine. Okay, here we had applied the four loading conditions and then we had specified the objective also. So one person may ask that, asked in chat box, just now I noticed actually, what basis the loading conditions has been defined actually. I already shared that image. So let me share that once again, the loading conditions. So the load, it may be act as like this one. So the loading condition one and then loading condition two, there are four loading conditions here is mentioned. So towards upwards, towards rightwards, and then it may be a static torsional effect, and then it may be some angle. So actually here it may be mentioned as 45 degree, as like that only I have represented. So these conditions are applied same as in one of the research paper. Let me show that too. So hope you see the research paper, right? So this is the combining macro and neoscale optimization, a case study of a General Electric jet engine bracket. So in this case study, they have taken the jet engine bracket and then they gave some load effect based upon the their reading while they're taking actually. Okay? So the same kind of effects, see the same values. This 35, 586 Newton, these values are only we have taken actually. And then I also shared one more image. This is this one. So this is normally the jet engine bracket looks like. And then these are the four bolted areas. So that's why we had constrained this as a fixed constraint. In this area, we may consider this as a fixed constraints actually. These are the pin areas. So we're going to generate this model only. Rather than this violet color portion, we're going to generate this model portions, these portions. Okay. So we're going to apply, actually we applied the load. So that too, I'm sure that in what basis. So these are the different loading conditions. Let me show that one now. So these are the different loading conditions. So towards upwards and then towards sidewards and then cross angle portion actually. So for that only we had given the load value on both Y and Z. And then this, it may be act as a tensional effect. So for this only we had applied the given the load value in both the directions. That is one side on negative direction and another side on positive direction. So these are the loading conditions we have applied so far. Okay. So let's come to the Fusion 360. Now we have completed the loading conditions and then we have applied the design criteria also. So that is we have to minimize the mass. Now we have to go to the manufacturing part. So let me click on the manufacturing part. So while clicking the manufacturing criteria, here it is shown as unrestricted and there are two manufacturing areas selected actually. One is additive and another one is milling. let us remove the milling process. Let us give some editing process only actually. Let us give some editing process only. So in what direction, overhang angle, let us give, excuse me. Yes, back. Sorry, some interruptions. Okay. So here we can give, yeah, we had selected the additive manufacturing process. So the material we can add on different orientation, X, Y, Z orientation actually. And then we can go ahead with the overhang angle by, here it was defaulted represented as a 45-degree. Let us change it to 50-degree. And then minimum thickness value, let us consider it as minimum thickness, lowest thickness, that is 0.05 thickness. That also we may consider this. Anyhow, we may generate a model with to reduce our mass. So we're going to create a design based for this manufacturing process. That is for additive manufacturing process. So this it may be the overhang angle of that my additive manufacturing process, and then minimum thickness it may be of 0.05 inches actually. Okay, let us consider this alone. So just give okay. That's all. So we had applied the design criteria and also the manufacturing criteria. So in what way we going to do some manufacturing process? Okay. Okay, let's go ahead for, then we have to go for material. So let us go for the guide. Let us check it actually, whether it is okay or not. Yeah, see, everything is, all other are same. Only the preview generate option is there. Okay, fine, no problem. Then the next we have to go for material, because by default the Fusion 360 takes the default material. So I have to change that material. So let us go for the material option. So go for study materials. So what are the materials used for this particular study? So that material going to be appear here. So a dialog box is appearing here. So in this dialog box, only one material is there. That is aluminum AL-Si10 Mg material is there. So method, it was in all methods actually. Just right click it and then delete it, because we going to add some other material. So here in library, there are a lot of materials are there. So Fusion 360, material library, additive material library, non-linear material library, favorites. So different kinds of materials are there actually. So you can use the material what you needed actually. So you can use the material what you needed. So here by default, one material is there. One material was there. I just removed that one. I just remove that one. Now I'm going to choose the material which is rugged for us actually. So let's go to the Fusion 360 material library. In that I am expanding the metal. Double click on the metal. Or just click on the metal. Click on the metal. One click is enough. So I'm going to add 4 materials. You can add a number of materials here. So the study will analyze all the materials and the loading conditions also. So in each and every conditions, it may check for each and every material you are going to add here. Okay. So let us go for stainless steel material. So in stainless steel, we may drag for 4 kind of materials. So let me drag based upon the paper actually. So steel ASI 446, and then stainless steel 440C, and then let us choose normal steel also. 1045. So 3 material has been added so far. And then let us add titanium also. So we had added 4 material. Now let us close this material actually. Now come to the screen. Now we had added, not possible to expand here. So the first one is stainless steel AISI 446, stainless steel 440C, steel AISI 1045390 QT, titanium 6AI4B. Actually, these materials are used for in that paper also. Let me show that also. The applied material was titanium actually. TI6AI4B. The same material we have utilized there actually. The fourth material which is used by us. See the titanium 6I4B. So this is the fourth material we are added. So along that we had added for 3 other materials also, stainless steel materials. Okay. So now the material is also defined. Now the material is also defined. Okay. Now we have to generate our design. So before that, just go ahead with the pre-check. So for generate option, the first we have to go for pre-check. Let me click on pre-check. Some bodies or components are hidden. If they are assigned obstacle, okay. So because we had hide one object, right? So let me unguide that one. So the pin is hidden. Let me unguide that one. So now it is unguided. Now just click on pre-check. The study setup has all the information required. So that is, if there is any problem, it will shows here. If there is any thing you had missed out or anything, the condition which you mentioned, it is not possible, it is not possible. That thing they will indicate here. You have to correct it. See, if it is in green in color means no problem. See, here itself it shows. Red means you can't generate outcomes because this ready setup does not meet some requirements. For example, there is less number of preserved geometry or material is missing as like that. If it is like, if that is like that means it will shows in red in color actually. If it is orange in color, you can generate outcome, but there are some potential issues. Some issues it may be there. A preserved geometry study includes minimum number of preserved geometries. That is not sufficient. If the starting shape body is missing, so as like that, some issues it might be there, but the outcome it may be get generated. If it is in orange color means. If it is an allowable issue, you may go ahead with the generate option, even though the pre-check is in orange color. If it is that that issue is allowable issue means you can go ahead with generate option. If it is red means, if it shows in red in color means you have to rectify that one, and then we have to go for next step that for generation actually. If it is green means no problem at all. You can go ahead with generate option. Okay. I just click on preview. So actually it is getting loaded because we are given 4 based conditions actually. So surely it will take some time actually. And then for generate also it is not possible for me actually. Today morning only I found out some issues in my credentials. For education license there is there is no problem at all for you purpose. For you people, you may get some education license, right? For education license, there is no problem to generate the generative design. So you can click generate button and then you can get the thing what you needed actually. See here, I have some credential issues. The cloud credits are not there. My account has some issues. So that's why I can't go with generate option. For you people, it is not a problem at all. You can go ahead with generate option. Okay. So after generating, you may get some pictures, output values. There you can choose the designs based upon your requirement for each and every metal, for based upon the mass, based upon the loading conditions. You can give, you can get the materials, and then based upon the material also you can get the physical properties. So if you give this material, if you choose this material means what would be the values and what are the designs available. So different designs would be generate actually. You can choose based upon your requirement. Okay. So here export generated results are there. Here we can't go ahead with because we not yet generate the results, right? So there are no outcomes to view the export it. We like to generate outcomes now. If I click on yes means it right has to generate, but my account has some problem to generate the generate designs. So that's why I can't explore it. But surely I will explore with some other account or after rectifying my account by tomorrow. After rectifying my account by tomorrow, I will show the results actually. Even if I click on generate now means even the cloud credits are not problem at all, not a problem. If I click on generate means then it will take long time to generate the results. Okay, so anyway it will take some time. So tomorrow I will show about the results. So what are the inputs? What is the result for this particular problem? Okay. Okay. Any doubt on these things, these areas? We will discuss the result on tomorrow's class. The generated design results on the tomorrow's class. How we can export the results as like that. That topic we will discuss on tomorrow's class. So any doubt on this generative design part? Sorry, just now I noticed here some of the questions are there. How do you apply the design morphology for a new product? For a new product, you have to give the conditions actually. So based upon the conditions, you can give the apply material as like that, you can do it actually. That is not an issue. So here I had taken it from a research based paper and then I just apply the conditions. For a for a new product, you may get no that is where you going to be used and where you going to be what are the effects going to be there. As like that, you may have some idea. So based upon without some requirements, we need not to go for some new product or new design. So based upon the requirements only, we go for a new product. So that requirement we may consider it as a conditions here. So that thing you're going to apply it over here, and then you may get a designs. That's it. And then how to add a new material, for example, nano material to the library. Yeah, that I will surely tell you. Actually, that is the material here. Manage physical materials is there. Sorry, I forgot to share my screen. So, okay. So just go ahead with the materials. Here, the manage physical materials is there actually. So let me click on here. So these are the materials which is already available. The physical material, that is a Fusion 360 material library is there actually. So different kinds of materials, it is already material available is there actually. What are the materials which was available in, and then see different kinds of materials here. Legacy material, adaptive material, non-linear material, appearance material, as like that. Okay. Even we can choose some of it as favorites also. And then here there is an option called create and duplicate materials. Click on here. So create new material. Click on here. Sorry. Some issue in my. So here some material, the newly created material. If you click on here means you can give the name actually default new material here actually. So you can give the manufacturer model and then what the kind of material it may, whether it may be a metal or some other else. So you can apply the different material. So if you go with metal, you can give it actually. Then click on plus add. Go with the physical things. So just choose open existing library. So here you can give it actually. So here there is an option for adding the materials or the physical properties. We can mention it actually. So default new material, here some editing process. The same thing here. But you can change what? You can change the physical properties of the material also. I'll show it by tomorrow's class. Any other doubts? So one thing I have to show it, that is how to change the material. That is how to add a new material. So that thing I have to show it. Let me show it by tomorrow's class. Come to the last date for submission of assignments. So for assignments, I also have to add that one point actually. See, for assignments, you need not to download anything. What they make, what the product you have created as like that, you need not to download that one actually. So you can simply share the link of that model. See how to create the link of the model actually. See, if this is the model I have to submit means, if this is the model I have to submit means, just go ahead with file. Let me save that one actually first of all. So first you save the file actually, then you go ahead with the file and then click on the share button, share link, and then there is an option called link. Just click on here link. If you click on link means yeah, share public link or share dialog box may get appear. In that share the latest version of the anyone using the link. So just click into the into mark here. See the light into mark is there now. Just click on here. So if you click on there, automatically a link will be generated for your model. A link it may be generated for your model. This link only you have to share with us. I will generate a Google form for submitting these assignments today, and I will post it in WhatsApp group. You may submit your assignments on that Google form link actually. So that is enough. So the sharing this link of each assignment is enough. You need not to download or you need not to send that image, everything. Okay. So that sharing this link itself enough. We will collect only the link of that model actually. We can see that model in our system itself using that link. Yeah, yesterday you not only user, a lot of members are asked actually about that assignment, how to submit that one. So I left that because I need to share this thing in our class itself. So that's why online class itself, while taking class itself, if I share means everything will, everybody they may get known. No? So that's why just I ignore that one and share now actually. Okay, now let us move on to the next portion. So let me open. Let me share my Fusion 360 screen. So the second option, that is assembly motion, just double click on this one. So now let us just hide my data panel. This is an assembly we have created. So this Autodesk file only actually. So what I had teaching all the models. So the same model and then this G bracket and then the Geneva mechanism. All the models are available in Autodesk itself. That is an Autodesk help menu. That itself there itself you can grab the models on that. So you need not to worry about it. Even you can grab that kind of this kind of models even in your dashboard itself. See, even in your data panel itself. See, if you go to the home view, that is home button. So here a lot of samples are there, right? Basic training, camp samples, design samples, electronic samples, generative design samples, simulation samples. So from here only I'm choosing all these models actually. Okay. So I didn't take any time to create these kind of models and all. So just here you have all the samples. See, for practicing purposes, you can placing these things actually. Okay, now let us consider this for assembly motion study. Okay, so now let me see. Okay, just click and then drag it. So just click and drag this one actually. See, it is moved towards front and back, but actually there is no restriction at all. There is no restriction at all. Even it is collide with the object and then move along that object actually. So, but practically it is not possible. See, from in backward also, it colliding the object and then it move along the object and then more actually. But practically it is not possible at all. Okay. See, if you change some movement, if you give some movement and then if you change in your design by uh, this kind of movement means automatically the icon will be here appear actually. See the position. Whether you have to capture this position as the current position. If you need to capture this position as current position, means you have to click on capture position. Here another one option is there, that is revert position. Revert position means you need not to capture this position. You have to come back to your original position. So you have, if you want to do like that means if you want to not to choose this position and you have to come back to the original position means you have to choose this revert position option. Let me click on the revert position option. See, the object comes to the original position. So automatically this disappears. See, if you move somewhere else other than the original position, automatically the position dialog box, the position icon will appears, position button will appears here. So in that, you may click on the revert position and then come back to the original position. See, after if you click on the revert position, it will come back to the original position actually. Okay. Okay. Now let us expand the joints. Let us expand the joints. See, a lot of joints may be there actually. Let me expand this one. What are the joints applied here? See, several joints are there actually. Lot of joints are there. Lot of rigid joints are there actually. Mostly rigid joints. Only three are movement actually. That is revolute 2 and then slider and another one is revolute 16. All other are rigid joints. All other are rigid joints. Only three joints are moving joints. That is one is revolute 2 and another one is slider 42 and then revolute 16. So two revolute joints and one is slider joint actually. Okay. Okay. Now let us select the revolute 2, right click, and then actually it shows some motion is locked. Unlock motion is the option is there actually. See, if you click on slider 2, right click, lock motion. But here it actually it is locked. So that's why here it shows it as unlock motion. So the motion is unlocked condition actually. Okay, let us leave that one and then move to the slider 42. Right click and then there is an option called animate joint. Here the animate joint is there. Animate joint is there, but it shows doesn't show some deflection because it is locked. Okay, right click the slider 42. So go with animate joint. The object is getting animated, but the object is moving by colliding the object. The object is moving by colliding the other objects. It is not at all possible. Okay? So it is not at all possible. So the right click the same thing and go with animate joint relationship. So there is no relationship at all. So that's why the object is moving in the same direction actually. That means only these two parts are getting related. It's fixed. So that's why it's going like this. Okay, go with revolute 16. Right click and then I go with animate joint option. So here this part is getting rotated. Here this portion is getting rotated actually. So right click and then go with animate joint relationship. So this object is merged with these two. even this also. So only these kind of objects are now rotating actually. So this is the difference between animate join and animate join relationship. If that object is what assembled with some other object with some constraints, if that object is rotate means automatically the other objects which is assembled with that particular object may also get rotated. Okay. So as like that only we are here we are seeing actually. We are doing that only. Okay. Now what I'm going to do is I'm going to give some restriction for this slider motion because it is not right. It is not at all right. So here we're going to give some restriction for slider 42. So how are we going to give the restriction? So you can apply slider motion, but how are we going to give some restriction? Right click and then there is an option called edit motion limits, edit join. So different options are there actually. So go ahead with edit motion limits. Here there are some options are there. And then here right click edit join. Here also some options are there. See in motion also here it has some join motion limits. The same thing what you have seen there. The same thing here also you can see it actually. Okay, cancel it. So slider 42, right click and then edit, excuse me. Okay, comes, sorry, some disturbance. Go with slider 42, edit, right click, edit joint, and then edit motion limits. Let us go with the edit motion limits itself. Only that part it will be there actually. Okay, here, let us move my drawing to the front view because this is the slider joint actually. Here only we're going to do some editing work. So let us give some limitations on minimum and maximum. So both minimum and maximum, okay. So here, if I click on this, see here only one arrow mark is there actually. If I select, check this, one flag is getting appear on right hand side and another flag is getting appear on left hand side. So two flags are there, left hand and then right hand. Okay, now let us move this left hand. Just click and drag it. Just click and drag it. Let us give until it moves until this face. Okay. So let us stop by 1.20 inches. Let us stop by 1.20 inches. Still some gaps are there, but here one more component is there now. So that is not visible here actually. It might be visible later because and then even the minimum also we have to give it actually. Minimum actually this is the right side flag. Let me click and then move it actually. So let us give it as minimum that is a 0.2 inches. That is enough. That is from here. From here we are giving actually from 0.02 inches. Okay. So now just animate the joint limits actually with the limits. Just animate here. So there is some minimum value and there is some maximum value actually. So based on this only here the animation is going on. So minimum value we had given value the value it as 0.20 inches. 0.20 inches. Okay. So let us stop this animation. Just click on OK. So now again go to the home view. Now again in the 3-direction view, just click on the slider 42 and then right click on animate join. So still that's what this portion is not getting moved. No problem. Just go with the right click, animate joint relationship. Sorry. We have to right click the slider 42 and then click on animate joint relationship. See the portion here. See, only little amount of portion is there actually. So for that purpose, I had given it as 0.2 inches. Okay, now let us press the escape key, because see, if you consider this, see, for measuring the distance of any model, you can use this inspect key, inspect measure. Just let me choose this edge and then this edge. So what is the distance? 0.188 inches. So this is approximately comes around 0.2 inches, right? We may see in about even 1.3 is also possible, but we are limited as 1.2 actually, because of this thickness actually. Okay, fine. So now what I have to do is let us remove this one actually. Let us enable the contact set. Go ahead with enable contact sets. So let us close the join and then move to the contact set. Enable contact sets. Now again let me enlarge, sorry. Contact set means right click the contact set and then there's an option called new contact set. Actually this contact set we had seen in yesterday's class. So just go ahead with the new contact set and then select these two portions. So these two object, it should not be get contacted. So if it is contacted, it should be retract. So just click on OK. So this it may be called as a contact set. Okay. Now expand the join again. Go to the slider 42 again, right click and then go to the edit motion limits. Remove this minimum and maximum and then click on the preview limits now. Oh, sorry. Just click on OK. Now go ahead with slider 42, right click and then animate joint relationship. So even if you apply that also means it is not there. The contact set is also not possible. Edit option. See, now you can, I just add the contact set value actually. So what I click on escape, click on contact set, right click edit. So I added the portions of this also actually. So then automatically what will happen? What happened actually? Slider 42, click on animate joint relationship. So even it is not moving some part than some other portion actually. So let us disable the contact set. So click on escape key. So let us disable the contact set. So if you right click the contact sets and disable contact means automatically it will remove. Then go ahead with the again slider 42, right click, again go with anime edit motion limits. So apply the same thing actually. Minimum it has a 0.20 and then I think even 0.219 inches. Until that it can be moved. Just click on preview limits. Yeah, just click on OK. Click on animate joint relationship. See, now it is moving Paka. So we can go it with until the maximum. Until the maximum we can go it actually. Okay, now what I have to do is actually this alone is not sliding. So based upon the revolution of this only, it maybe get sliding, right? So we have to link this slider and then this revolute. This slider is 42 and then this slider, this revolution is revolute 16. We have to link this actually. So for that, what I have to do is go with the assembly option. There's an option called motion link. There's an option called motion link. From there, you can link the motions. Just click on the motion link option. So I have to select two joints. So which of the joints have to be linked? So I have to link these two. So let me choose the slider 42 and then revolute 16. See, if you select this, automatically a dialog box it gets appear. That is slider 42. That is slides in Z direction, which is sliding in Z direction. Actually, it is automatically gets animated, but it should not be there. Let us stop that one actually. Okay. So for each and every, and then for revolute 16 is the rotation is based upon Z axis. For each revolution of 360 degree, one revolution of 360 degree, how much inches that sliding motion has to be happened? Yesterday, one sir asked actually, I don't know, I forget his name, Narayana or something actually. So here you can restrict the distance based upon the angle. Based upon the angle. So for one complete revolution of 360 degree, that it can be new only for 0.394 inches. As like that, you can give some restrictions. See, even you can change the value here. You can change the, instead of 394, you may give value it as 2. So go to the preview. So for more rotation, as like that, you can apply it actually. By default, it was 349, right? So let us give as leave as it is actually. And then reverse, that is also possible. Front and back. So in this way, we can connect the joints actually. In this way, we can connect the joints. Even one more join also we can join actually. Okay, here let us stop it here itself. These two join and sign off actually. Let me click on OK. What is the next? Next, let us go to the revolute 2 option. This unlock motion. Right click and then unlock motion. So now this it maybe get animate. See if I click on animate, this it maybe get animated. Right click and then animate joint relationship. The total object is getting animated. So the total bit of that object is getting rotated for angle of only 90 degree. It has some limits, edit motion limits. See, the minimum angle is 0 degree and then maximum angle is, it was set to 90 degree actually. So we can give the limits over here. Already have given actually, they have given the limits. Okay, now let us go to the motion study. Now let us go ahead with the motion study. So go ahead with the assemble option and then go ahead with the motion study option here. Choose this revolute joint. Choose this revolute joint. So here See, this is our motion study. Here you can adjust the speed, and then here you can add the values. In how many steps it has to be attained. As like that, you can add it. So here one gray color line is there, and then here one line is there, right? At this point, let me at this 20. So here 0, 20, 40, 60, 80, 100. So these are the number of steps. So that steps means it may be taken as a seconds also. The time taken as like that also you can consider it as it does. So from 0 to 20 steps, it has to be deviated from here to here. As like that, you can apply. See, let me double click on this area. Let me double click on this particular area. Double click. See here, the angle has been given it as 90 degree, and the step 20, it has been given it as, and sorry, from 0 angle also it may be taken as a 90 degree, and then for step 20 also it is 90 degree. Shall we change to somewhat different at the step 20? See here it is 90 degree alone. Here let us change the angle of deviation, it may be a 45 degree at step 20. At step 20. Now just let us move from here to here. See, this is 0. So this is 90 degree. From 0 to 20, step 20, it's moving, and then at the value of at the step value of 20, it may attain the angle value 45 degree. It may attain the angle value 45 degree. So from here to here, the angle is getting deviated. So from 20, it is on the same angle, that is a 45 degree. If you need to return back by the step 40 to the same, some other portion or 0 as like that, means you can add here also actually. That is not an issue. Okay, now let us, what we have to do is, let us take the next motion also. Let us consider the next motion. See, only one motion is there, right? The revolute motion is the only one motion is there. Now let us add the slider mechanisms also. Okay? So just click on here and then add the slider. So just double click on the slider. Just double click on the slider. Automatically the slider 42 comes over here. See the slider from 0. It is at the same position. There is no deviation at all actually. So we have to give some deviation on this slider. So what kind of slider, what kind of thing it has to be given actually? We can, it is a slider mechanism, right? So we can give only the distance. We can give only the distance. The distance is also we are restricted from 0.2 inches to 1.21 something inches actually. So we had give some until that inches actually. So let us change something. What I go to do is until this 20, after this 20, it has to be vary actually. Let me double click on this portion. Here one step, distance is there. And then let us consider one more step it by here. That is 0. Let us change the value as 0.55 inches is there. Let us consider as 0.575. Make it as 40. So now just move it. So it's not actually properly viewing. Let us deselect it and then remove this point. Let me remove this point and also this point. So we can easily remove it. That is not a problem at all actually. Just double click on this actually. Here it is there. By default, now it is 0.40 inches, right? sorry, click on escape, go with the again motion study. Just select the revenue 2 and then double click on the 20, give the value as 45 and then add this slider 42. Just double click, automatically the object will come over here. So just click on here, add the point over here at 20 and also add the point over 40, give the value at 30 dash 0.7 inches, make it as 30. So now you can play. So play from 0. So here only one more. So if it has to be play forward and backward, that also you can play it. Actually, click on play. So it should be in repeated mode. Click on this and then play it. So from every time it will start from scratch. So if it is forward and backward means it moves forward and then it comes to the rest position. It move forwards and then operation can be done and then come to the rest position. As like that. See if you need to adjust the speed over here. So in different angle you can see that one actually. So only minimum number of inches we had given actually. So let us and then change, let us make the changes. Instead of 0.7, let us consider it as 0.9 inches. Now let us go with the play option. See, this kind of motion study we can do it in Fusion 360. So actually here I have only applied only 2. You can apply n number. You can apply n number here actually. So even you can add revenue 16 also. But this position only has to be rotate as like that, we can add it. So here the 45-degree angle as mentioned, and then 0.5 inches some angle values are there. So if you need to remove any joint from this motion study means you can simply remove it actually, that's not an issue. And then you can add it just by double click on the joints. This is a simple process. Just click on OK. So come see, the position is deviated. Automatically the position option is come and then here come to the revert position part. It will brings back to the original position of the particular object. So in this way we can do the motion study also. So any doubt on this? So before getting into this, actually we have to understand the see, let me do one thing. Let me share the screen again. So you have to understand about the joints actually. So revolute joint, what would be the thing it might be? See here, right click, go with the edit joint option. So this is the option we are applied here. So we are applying the edit joint, we are go with the edit joint option, go with the motion option. See, it is a revolute joint. The rotation is about z-axis. The minimum angle it might be of 0 and then maximum angle it might be of 90 degree. See, now the angle it is 0. Go to the preview limits. Now the angle is 90. The minimum angle is 0 and then maximum angle is 90 degree. We have mentioned as like that actually. So initially it will be in 0 position actually. It will be in 0 position. Maximum it will revolve for 90 degree. That's all. So these kind of things. So this is based on revolution motion, right? So based upon the z-axis. So if you apply on y-axis means it is not at all possible. So in this way only. So we have to be very careful on which axis we have to be combined as like that. We have to be very careful actually. 0 to 90. Maximum is 90. Some warnings are there actually. So as like this slider motion also. So go with the edit joint option. So this it can be slide. Go to the motion option. See, these are the limits we are applied later. But this is the motion, slider motion, and then slide along the z-axis. So we have to be, we should have some idea on these motions actually. And then I observed on yesterday's chat box how the constraint it may be given actually. You go to the join option, see component 1, component 2 is there, origin mode, see what are the things you have to apply. So I have to bring a cylindrical portion and then I have to apply a constraint over here or some other part. So for that you can go with this. So if it is fixed means you can go with the rigid option or else you can go with some other options actually. So based on that only we are giving joints over here, constraints. So here there is a lot of, in earlier days we are using some constraints. That is what? Mate constraint. That is a mating between one phase to some other phase. So that kind of constraints we may give actually, right? So instead of that, here what we are giving is a rigid option actually. Instead of that, we are giving for rigid constraint. Or else here also see join also here this rigid option is there. So you may use that one actually. So instead of that mate based constraints and all, you may use that also. So like that only you are using. And then here the rigid group is also there. Even if you need to fix a group of object into a rigid manner means you can go with the rigid group option actually. So actually we didn't see even you can go for rendering modeling. Let us show one more model. Let us check another model. Let us choose the ramp shape. So hope you all aware about the rendering, right? So that is we're going to convert our model into a realistic images. So for that I'm just going with the display style, visual style, it has shaded option. Now let us go with the rendering option. So click on here design and then move to the render portion. So click on render. Automatically this will switch over to the rendering environment. See, this is a rendering gallery. So if you perform any render means that image will be stored here actually. If you perform any render option means that image will be get stored here. So here the appearance of the object, you may change it here. And then decal, that is any kind of image you have to be paste here, means that also possible. So let me click on decal and then insert any other image. Let us bring this hook image itself. Click on open. Select the face. Let me choose on this face itself. So we need to scale actually. Let us consider the scale value. Scale it as 2. Scale it as 2 in Y direction also. Z direction, XY plane, that is also 2. That image, it is applied on the top portion. Just click on OK. See, now it is getting applied. Even you can adjust that one actually, that is not an issue. This is shaded profile. Come to the settings, environment of library. So let me undo the process. Okay, as like that you can do it actually. So go to the appearance option, first of all. So here a lot of materials are there actually, faces in this design, what kind of material we have used, and then different kind of library materials are there. And then what I am going to do is let us apply some material on here. Glass, fabric, waste materials, miscellaneous, carbon, yeah, rubber is there actually. So let me give this rubber material to somewhat for this object actually. Okay. So just download this material, even this rubber method also. So it is downloaded, just click and then drag it. See, while dragging, automatically it should highlighting actually, right? The object. Even the browser is also it's get highlighted. So if you move your cursor here, automatically it was highlighting the browser also. Just paste it here. See, now the material is applied for here. And then let us apply different metal. Let us apply copper, raw copper, polished copper. The options are there. Let us apply the raw copper for this one R. See, the copper material is applied. And then for this one, glass based material, smooth glass. Let us apply glass clear, glass gray, glass clear, white kind of glass. See, it is a transparent, it is a glass material, right? So automatically it is shown outside also. So let us apply glass gray, sorry. Somewhat. Anyway, it is glass. Okay, let us close it. So now we had applied the materials and then scene settings, how the scene settings it might be. So how we have to be show our environment and then what the brightness it should be. See, if you increase the brightness, automatically the brightness also get increased, right? So you have to apply normal actually. So by default it has some. Let me give as like based upon our requirement. Let me give some thousand value, thousand value, let me give some 2000. So this is what, okay. And then background color, solid color, actually it is the background of here. Just click on here. If you need some other background, click red and apply. See, you can apply what are the background you needed, that we can get it actually here. Okay, let it be here itself, this itself. Even this, instead of click on OK, even you can apply environment background also. So if you click on environment, you have to choose some images. In ground plane is there actually, flattened plane is there, reflection is might be there. See, if I click on reflection, see the object is getting reflected as like a mirror image actually. Flattened ground or ground plane, as like that we can choose it. Let us go for solid color itself. It remains as like this. I think this is fine. And then we have to render it actually, right? So just to click on, so we already seen the decal option. So just to click on in canvas render. So it automatically the rendering portion, it will render will take place here itself. This object is automatically convert into image here itself. See, there's elapsed time 9, iteration numbers is going there, excellent is there, final is there. If you go with excellent is good enough. If you need to move further means you can play it here again. So let us move this portion to the final actually. This drag up. Okay. Now the object is the render is completed actually. So just go to the capture image. In canvas render stop. If you click on play, it may automatically get played. So before getting into this, what you can do is you can zoom the portions, whatever you needed actually. You just keep along that path. So this is the portion I needed actually. So total number of iterations here it shows 26 so far, 27 actually. Elapsed time is 47 seconds. So I need to capture this image. So let me click on this capture image. So whether the current the document size, it might be of the current document window size. Yes, of course, it might be as like that only. So just to click on OK. So even you can change the image resolution. I already said some issues there in my license actually. So that's why I can't go for further. Okay, let us go for lampshade. Here it has to save it actually. Save to a project in the cloud, and also we will save to my computer also. So for computer, where the location might be, let me choose this, double click, break 3, then choose lampshade before it has saved. If you click on save button, it will save on both the locations. It may save on the cloud and also it may be save on my computer. Just click on save it. Just click on save it. Now now let us go and see in our window. This is the image we got. So let me stop the screen and then share the images. So this is the image what we got actually after rendering.
Sure, sir.
Sorry, sir. Okay, this is the image you may get after rendering actually. Okay, let us stop our session as of now. Let us
Yes, sir.
complete it. So if you have any queries, you just post your queries in chat box, or else you may raise your hand. Sir will unmute your mic and then you may clarify it.
Thank you, sir. Thank you very much.
Thank you, sir.
The participants, if anyone wants to ask any questions, please use the hand raise option so that we can unmute your mic. We have an announcement. Please know that tomorrow we do not have a session due to Bakrid. Tomorrow we will not be having a session. So we will again continue with the session on 30th, that is on Friday. Tomorrow, Thursday, we will not have any session. Please note that. We will continue our session again on 30th, which is on Friday. So on Friday, sir will be discussing on how we can do the PCB design, the schematic drawing and PCB manufacturing, followed by CAM, all CAMs, introduction, setup, and post-processing for CAMs. So please make sure you'll be available on that day, 30th. Please note, tomorrow we do not have a session due to Bakrid. Any questions from the participants? The participants, the feedback form has been sent to the chat box. Please use your registered email ID to fill the form. Yes, sir, I think that will be all.
Okay, sir. Okay, fine.
Yes, sir.
So
Maybe.
let us resume the session by day after tomorrow.
Yes, sir. We'll resume the
Morning
session
time by
day after.
10 o'clock.
Yes, yes, sir. Thank you very much.
Fine, sir. Fine. Thank you, sir. Thank you.
Thank you so much.
Sir,
Yes, sir.
then sir, kindly share the feedbacks of each day sessions to myself, please.
Yes, sir. Yeah, we'll share. Yes, sir. Yes.